Basically, the BERT model is in the whole transformer architecture where you have encoder, decoder. The encoder is the BERT and BART is the decoder.
Hi, everyone, and welcome to this episode of the podcast. Today we have Karol Gawron, who's representing bards.ai. It's a consultancy company that mainly deals with NLP and different machine learning solutions for various companies. So, Karol, thank you very much for joining today.
Thank you for inviting me too.
Would you mind, before we get started, to introduce yourself briefly and how you got into the NLP space in particular?
Yeah, sure. I'm from Poland. I'm now co-founder of bards.ai company, as you said before, and I also work in research project at the University of Science and Technology in Wrocław. And I got into NLP by my, I don't know, maybe it was uh, from that as a kid I always wanted to be a scientist. Then I found out I like computers, so I got to the computer science bachelor degree, and after that I found that there is something interesting like an artificial intelligence field, and we have master degree at our university. I got in, and it got really interesting to me. So now I'm passionate about it, and because of my mentor at studies, he invited us to this research project, Clarin.pl, which is mostly developing and researching NLP solutions for Polish language, and that's how I get into NLP.
Mm-hmm. So that was in your master's that you got into it, or did you already have some exposure in the bachelor's?
No. I always wanted to, but I didn't have time, and I was also part of the students' union, so I did some other stuff than computer science. So yeah, it was on my master's.
Okay. And if we talk briefly about the research project that you was involved in at the time, what were you focusing on? So you mentioned NLP, but more specifically, so what parts of NLP applications for the Polish language were you investigating?
Yeah. My first project, as I remember, was geocoding or geoparsing also. So you had like a bunch of books or text, and you wanted to find the locations specified in text, and then change these locations into coordinates. So you can just pinpoint points on the map where where the plot or something like that from the book happens. That was my first project, as I remember. And then I did some topic modeling, particularly short text topic modeling. So it was really tough at the beginning because the classical methods didn't work that good on tweets because there are not too many words that co-occur in tweets. But I found their topic solution, which is great, and I recommend it. And it works very well. There was also multilingual model there, which works for our Polish tweets. And yeah, that was one of the projects.
So if I can just interrupt there, what did you actually use for that? So what solution were you in the end using to interpret those tweets?
BERT topic. So it's BRT topic framework, which is now improved by this time a lot, and it works really well, especially for these short text that don't work in these classic solutions, because it's based on the vectors. So this context representation of the sentences, so it works better because the words do not have to be exact the same. It just have to have the same meaning or semantic meaning.
Mm-hmm. Can you quickly describe the transformation between words in a text that you analyze to the internal vector representation that a model like BERT uses for people that might not be familiar, and what the use case is for that as well.
Okay, so it's work kind of like magic, but basically it's that the BERT models or any really computer artificial intelligence models works on numbers. So they only understand numbers, not text. So what you do now is just change like bunch of text into tokens. So it's like word or maybe part of the word. You change it to like one list of numbers, like 520 numbers, and that's kind of like representation of a number of this word. And at first it was some word to vec or fast text solutions, which gives each word one this one number. And how it works, it's that if you want to visualize, like if you will plot these numbers on a space. So, for example, if you will change word to two numbers, and you will use one number as an x and the other one for y axis, you will have something like points, right? And computer understands that maybe dog and a cat are more similar, so the numbers will be more similar than, for example, a computer, because it's a lot, it's other thing. And with the advance of our NLP, it turns out that you could represent the whole sentence as a one set of numbers, these vectors, like 500, 1000 numbers. And if the semantic meaning of a sentence will be similar to other one, the numbers will be also similar. And in the computer you could compare numbers, right? But you can compare words.
And if we talk about BERT in particular, so that's a large language model, when it comes to training that on the Polish language, is that something the university has a version of, let's say a pre-trained model? Because I guess what you did was fine-tuning to a particular application, because the entire training set that you would need is very large for those kinds of models. How does that work for a niche language like Polish?
Okay, so first of all, we have the BERT trained by word masking on a large Polish corpora. So we have like base BERT for that BERT, and there are also, which I used at the time, multilingual models. So they just say that if you will just use some paralingual corpora like sentences in Polish, English, and I know Hindi, which means the same, you can make a model that is based on English, but that it could work also for the other languages, so it represents text in the same way. And other thing is, as you mentioned, that it might be a low resource language like Polish, hard to find some annotated examples, but you have solutions like transformer autoencoder, TSDI, something like that, that you could use to fine-tune the model on the raw text. So you don't have really any labels there. The model just tries to compress the whole sentence into one space, and as an autoencoder just get from this representation text back. So it kind of learns how to represent the best way, how to compress this information into one vector. And you just need to gather some, text from the internet or something like that, or from books. You don't need any labels for that.
Mm-hmm. And how did you go from the research project that you were working on to the company that you now started? So I know the company is 4 people, and were the co-founders there all present in this research project, or how did you get to know each other?
Okay, so first of all, we get to know each other before the research project because in our degree, which is like 1.5 year, they at the beginning propose you to form up a group of people and work on one big project through all these 1.5 year. So you could make some modules for it or something like that in all your classes that will work with it. And you have like different types of projects you can start. One is more like paper science specified. One might be like for social impact, so you want to maybe check how the city works, how you optimize something there. Or as we did, you could choose to have some project that will be something like startup, some business project. And we wanted to do something like Grammarly, but for Polish. That was our goal. That's how we group up. And then through all these studies, we worked together on all projects we can. And we also found the same mentor, and he invited us to this research project. So we work there together. And then after we graduate, we wanted to start a company. We make some changes. We found out that there is other company that already works on something like this Grammarly for Polish, but it's already started and it had a bigger, uh, mm, experience there. So we just finds out that we will do services like software house, but specifically for AI.
And how did you find the first customers when it came to that?
We find the first customers by word of mouth, but also we tried doing the competitions, the hackathons. We thought that if we will win a hackathon, which is competition where you have like 24 or 48 hours to do some concept work and make some prototype for the specified task, like a search engine for historical data for Polish Institute. There was something like that, and you can win money there. But we thought if we will win, we will come to them and we will say, hey, we could make this project like in real, not in 24 hours, but in real. So we tried that. We won few competitions, uh, like few of them, one by one, but it's really just I think it was only one project for our company from this idea.
Okay. How harsh is the competition when it comes to other companies that are trying to do the same? So, in these competitions or hackathons that you were on, were there lots of other similar service based companies, specifically for AI, that were also trying to compete in those? Or was it mainly private individuals?
No, it was mostly private individuals. At the beginning we were also private individuals somehow because we didn't have formal company yet, and yeah, and really not much of them knows AI, so they were making more like typical computer science solutions, web apps or things like that. And I think because of our AI specialization and the effect this wow effect it makes, we won few of them.
And the other three co founders of the company, they also have then a similar background in the AI field, or are you more diversified in terms of maybe someone with more business background, or how is the split there?
Okay, so as I said, we group up on our masters, so we all did the same master data science degree, but we came from different bachelor's degree, but all kinda in computer science. But So the education background is pretty similar, but we have different backgrounds. Like I did a lot of work in students council, so I have experience with projects, some or organizing stuff. One of our co-founders already had a startup before. Uh, yeah, one maybe is more technical, but yeah, more or less we have the same background. Yeah, but maybe I can also say that uh, it it's now turning out who wants to work where. So we have some like personal traits that push us to, more client or more technical work.
And speaking of the work in more depth now, the kind of things you're doing on a day to day, I had a look at some of the publications that you've made recently, so during 2022. I figured we would talk briefly about those. So, in particular, two papers that I had in mind. The most recent one, or the first of them that I would like to discuss, is the one you published on multi-module natural language search engine for travel offers. So, would you be willing to give a quick overview of what that project is about in large?
Okay, so it was part of this research project that we worked on, and there was a travel tourist company there working with this research project that wanted to make this finding your dream travel offer really convenient by just typing in what you want, and we will just it sounds like a natural language processing, so we just tried a couple ways to make that happen.
The idea is then you would, instead of having these options that you normally have on travel agencies, just have a search field, let's say, and the end user would type in, I want a trip to, I don't know, Greece in the summer or whatever, and then you would get some suggestions.
Yeah, exactly.
And what were they using at the time? So before you started the project?
I'm not sure because I really got into project in the middle, kinda. Uh, but uh, but I think they're also a new company, so they might did not use anything or just use typical search. As I recall, they were also, you know, using people, as it might sound, but they will just have these specialists that, you can do something similar. You don't type, but you say, I want summer vacations in Greece with my kids, and they just know how to find it. So it's kind of like replacing the humans to the automatic system.
Hmm. Okay. And so you were faced with this problem, and what was your strategy for trying to solve it? What was your thought process?
Okay, when I got into it, I thought it will be it's kind of similar to Q&A problem, so question and answer problem. So for a given question, you want to find the best answer. And I did some research. I find out that the state-of-the-art BERT models, properly trained, can do really nice solution there.
Hmm. And the final architecture that you went ahead with is quite a bit different from just using a traditional BERT architecture. So, can you describe briefly what the architecture is?
Okay, so there was really a few teams that work kind of independent on it. So we have different ways how to make that happen. As I said, it was research project, so it was a lot of research to do there, and different ways to make the same. And as we work through these different modules that works differently, we thought that the best way will be to use all of them, just like you use ensemble models and some solutions, and try to combine them somehow in this system. But it will have to be production system at the end, because as I said, it was real company that really wanted to have that in production. So we used a Solr system, which is something like Elasticsearch, to combine them.
Okay. And can you briefly describe the different modules that you were using?
Okay, so one was the metadata module, which is, you might briefly say that if you have an offer which is tagged by people, you will have like, Greece, hot, or maybe summer, things like that, which are somehow describe the text. And you could, based on the text of the offer, try to automatically find them. So you want to find the entities there. So if there is a beach, if there is a pool, or things like that. So you just use the named cognition model, and you could do the same for the query. So if someone writes Greece or something like that, and you have tags on the offer side, on the query side, and you could find the best matching there.
And what do you use to tag those?
It's pretty complicated pipeline. My colleague works on it, but I can say it was based on our this research project Polish NER implementation based on Roberta architecture. Mostly, but there was also some some other morphosyntactic taggers and things like that to find the pronouns and things like that.
Okay, so that's the first module, and then if you go ahead to the other ones.
Yeah. The other one is the ontology-based text matching module. So if you will look at these categories, but from the distant perspective, it might happen that you can build some ontology on it. So I don't know, you have like one node of activities, and these activities can be different, like sport activities, and then you can split the sport activities into like basketball, volleyball, and things like that.
Mm-hmm. And with this, just to interrupt, would that be an ontology based on the search query, or are you talking now about tags for the, for the vacation destinations, or both?
For everything, really. So you have this ontology for destinations, for the attractions, for the time, and things like that. And as I recall, my friend used some like semi-automatic way to build this ontology, and then with some people work, they improve it to the end form. And then you want to have some kind of model that find this specified ontology in the offer and in the query also the same way. So if there's a beach in the offer and in the query, it doesn't have to exactly be write it down as a beach, but maybe they saying that it's near the sea or something like that. So you will use some text embeddings and some model. My colleague used release something like CNN embeddings and some I think MLP model to just classify that from the text. So you will have these like there was I believe like 2000 categories and you just classify if there is this class in the text or in the query.
Mm-hmm. And from my perspective, it sounds quite similar actually to what the first module does, if I understood this correctly. So the second one is ontology based, and you build this ontology based on the keywords that you've been able to find.
Yeah. Okay. I the difference is that in the first one, you just find these entities, but it's like open, so you can have as many entities as you can. And in this ontology-based method, you have this closed ontology, so you only classify to the classes you specified in the ontology.
Okay, so the ontology-based one helps with limiting the number of categories. Is that a fair statement?
Yeah. That's the first statement.
Okay, cool. So those are the first two modules, and then you have a third one as well.
Yeah, that's the most end-to-end module, I think, because it's, as I said earlier, just Q&A, one of the state-of-the-art Q&A solutions. So you just have this vector representation module, which can be BARD or something like that, and you just train it so that the vector representation of an offer and a query that matches the offer will be similar, right? So it will be close in this vector space, and the other ones will be more far away. So if you will just use cousin similarity on all offers, you could just sort them out by the relevance to this query. So it's the most of work there was to build the app to annotate the results because it's hard to we really tried different ways of writing the positives and negatives and things like that.
And to be clear, what do you specify as a positive and a negative in the training for this?
Okay, so one way is to specify only positives, and positives are the offers that match the query as a whole. So if you want the vacations in Greece in summer and for kids, you want the offer that's exactly in Greece in the summer and there is some attractions for kids. It's not really, you can't really know sometimes exactly if it really matches, because if someone says it have to be cheap, what does it mean that it's cheap, right? So we have these 2+1 annotations, which means that at least two people annotate the same pair and say if it's good or not. And then if they disagree, there's third person that do the same, and we choose the answer which turns out twice.
When you say two people that annotated, those people that did this, was that something you were doing yourselves as part of the project, or were you able to somehow outsource this in some fashion?
Yeah, the research project we worked in had the special team for the annotations.
Okay, but it wasn't like questions that you asked to everyday people that were using the system, but it was people specifically devoted to the research project that was doing that as part of their tasks.
Yeah.
Okay.
Yeah, exactly.
Okay.
Yeah, but we had to, work closely with them to specify which queries should, be positive or negative.
If I recall correctly, you had a fixed number of results that were allowed to be positive. So you display like the top 10 or something like that. How do you, first of all, is that correct? And if so, how do you decipher between what goes into that list and what doesn't, in case there are more queries that actually match the results?
Okay, so you're saying about the final results, right?
Yes, or what's being used for the training. If you're using all positives and negatives, or whether you're expecting a set as the output.
Okay, we have like different ways of making these positive and negatives. One was to just see the offer and write a query that maybe matches this offer. That was one way, because we have like this data set of offers already, like in thousands. We didn't have queries, but we did an application which works on our baseline model, which lets you write whatever query you want, or just use the one that was already there. And it uses already a working system to find the best matching offers in the whole database. So there's a chance there will be good ones there. And you would just read one by one every offer and click if it's positive or negative. That was the creating dataset stage. And I can also say something that might be interesting. There are multiple ways of training these representation models. You could use these positives and also the negatives to make these triplets, they called. So if you had like the anchor, which is our offer, you have the positive example and the negative example. You can imagine that you want this positive example should be closer in the vector space than the negative example. But you're still pretty limited on the combinations and negatives. So the best solution that worked in our case was not using negatives at all, the ones that we labeled, but to say that we have this big data set and most of the offers aren't really good for the query. So probably only few of them will be positive, right? And the whole database for a given query. So you just take a batch of these queries and offers that match them, and say that only the positive one is positive, and all other ones are negatives, because probably they are. But you just assume that yeah. So now you have like a lot of negatives there. Like if you have batch of 8, you have 1 positive and 7 negatives just from nowhere. You didn't have to annotate them, and it really worked in our case, and it makes the model more robust and gives the best results.
And so in the end, with these 3 modules, did you evaluate them separately, or did you just build a compound model from the start, including all 3?
So I think we built the compound, but also we tested how adding each of them worked, and summarized it in our paper, already the best of them. And we also tried to use only the vector module, because it was really promising. And it turns out only the vector module was better than combining all of them.
Okay. Why do you think that is? Do you have a theory why that one performed so much better than the others?
I think it's that it got really robust because of the training process, and also I think the other modules didn't have that much of training data there.
How come you weren't able to use the same training data for the vector model as for the other 2?
No, we have different training data sets for each of the modules.
How come? So what's the reason for the difference in data? Because my understanding was all of these modules have the same input and the same output that you're trying to generate.
Yes, but not. But the models working there have different outputs. So for the vector module, what your model outputs a vector, right? And then you could just compare the vector of a query and offer, and with causing similarity, and you have tell what's the losses. So if the query should match the vector, it should have a really big causing similarity, right? But on the other modules, outputted something else, like the ontology modules output the classified nodes from the ontology, right? So if there's a pool or something like that, and you could compare the query and the offer, but you can't compute the loss in that case, because your loss is based on the classification of the an entity only. So you have data set where you have annotated onto like these entities, and the same goes for the metadata module. You could compare default entities, but you can't use them really to train the model.
Okay, so the main, let's say, idea behind why the vector-based model in the end, or module, performed better than the other two was because you had more robust training data. Were there also any shortcomings with the other two? Like, let's say the ontology-based one, how did it work in terms of the limited set of categories that you had? Did you notice, let's say, a discrepancy in performance between the metadata and ontology-based modules?
I know it's hard to say. I didn't work on that module, so I didn't saw any more in-depth analysis there. But I don't know. It will probably need another paper to check that out.
Okay, cool. So moving on to the second paper we were going to discuss, that's the deep neural sequence-to-sequence lexical substitution for the Polish language. Can you briefly explain what you did there?
Okay, so we wanted simply to replace one word in a sentence for another, preserving the meaning, and yeah, and simply that's it.
Mm-hmm. And what is the use case for that, or what led you to that requirement?
Okay, so as I said, we wanted at the beginning to make something like Grammarly for Polish, and one of the cases was to maybe improve your writing, to change some words to the others, to I don't know, maybe don't use repetitions, or just use some other word that might be more professional or things like that.
Mm-hmm. Okay, and for the architecture that you used, I know you used BART and BERT to compare these. Can you briefly discuss what the difference between those two models is?
Okay, so the BERT model is the model that is trained on the masked words. So you just have the hold sentence. You can mask the middle of it, and the model will try to guess what word should go there. But it sees the left side and the right side. On the other hand, the BART module is the decoding model, so it will just try to predict the best next word from the left to the right. So it only sees the left part, and he just tries to predict the next word. Basically, the BERT model is in the whole transformer architecture where you have encoder, decoder. The encoder is the BERT, and BART is the decoder.
Is there any situation where you would expect BART to outperform BERT? So the information that you feed to the model seems to be superior in case of BERT, because you have both the context leading up to the word, but then also the context following it. And naturally, that's more information contained than simply saying the only thing we feed it is the part of the sentence leading up to the missing word.
Yeah, the case is mostly when you want to. Okay, as I can already say that in this paper we wanted BART bet more because it could generate few tokens like in one inference time, because it will just it can generate left from the right, but you don't need to say how many tokens how many words you want. On the other hand, the BERT model needs to exactly know how many tokens you would need to fill in the middle.
You said that for the BERT model, you need to know exactly how many tokens you want to replace. When you say that, do you mean you need to know exactly how many characters are part of the word that you're trying to replace?
The token is probably one short word on part of the word. So it depends on the tokenizator, which is a thing that cuts the words into tokens. And most like we probably is one token, but something longer like example might be from few tokens like exa and ample, something like that.
Okay, and for the application of BERT, how do you arrive at the number of tokens that you're looking to replace? Do you know that from the beginning? Or do you use some other model to tokenize this text and then replace it?
We will just trying to predict maybe one token, two tokens, three tokens, like uh, few few different ways, and yeah. So we didn't know.
Okay, and what's the reason why BART doesn't need to know that, but BERT does? So presumably the architectures are quite similar. You mentioned that the first one relies on the encoder of the transformer model and the other one is the decoder. Why is there a difference in how many, well, in the need to specify the number of tokens on the one hand, but not for the other hand?
Mm, I'm not sure. That's maybe the training perspective because uh, in bird training, it always you always mask exact number of tokens, and it just learns to predict these tokens only. And in the BART architecture, you have loss based on each next token from the left to the right, and you could, just goes forever, right? But you can also say that's the end at some point.
Mm-hmm. Okay. And in addition to the two models you investigated, you were also using a couple of different data sets. Could you please describe the two data sets that you used and what the difference was between them?
One was one was a Wikipedia data set um, when you had sentences and the editorial history of the sentences. So you know that there was like a sentence and someone changed the word in it. Like it's Wikipedia edit history. And with that, we just assumed that if someone changed a word from one to another, it might just be a better fit, but probably it means the same, or something like that. That was our assumption. And the other one was using just one of the Polish text documents dataset and use some pipeline to replace words there with another words with the same meaning, but like from the WordNet, Polish WordNet. So
What is Polish WordNet?
so it's these uh, big kind of data set where you could search for a word and see this word from like different angles. Like you could check the meanings for sure. You could check if there are some homonyms or things like that. I don't know the names in English really, but if there is like, oh, if there's a car, you could check that there is machine word which is more general for this, and things like that, like a lot of information for every word there. And you have also same, yeah, and you could check the other words we have which have the same meaning.
Okay, so in essence, you were comparing a pre-formed data set from Wikipedia with people replacing words to a synthetically created one that you made yourself, where you tried to replicate, what a word replacement might be, and then train a model based on that.
Yeah.
What were your findings? So comparing these two models, but then also comparing the two data sets.
Mm, I think the Wikipedia dataset was better because it was like not synthetic, not made up by us. So it had better quality. So it worked kind of better. But as I remember, I could check that if combining these two data sets give the best results. Uh, but mostly the Wikipedia-based dataset was the main contribution for the performance of the model. And I also think that we just used BERT as a baseline model, and we just only trained the BERT model for these replacements because yeah, because of the because of the cost of the computations on the BERT side, because you have to try this different number of tokens each time.
I see. And when it comes to the synthetic training set that you were using, did you create the pipeline for that yourself, or are there any off-the-shelf solutions that you can leverage?
No, we used the ready solutions, but we created pipeline from it. So we used the already existing morphological analysis for Polish and syntactic tagging. We used this word sense disambiguation model for Polish. So yeah, it was from the ready build blocks that we built the pipeline.
Do you have an idea why that underperformed the Wikipedia page? Because I would understand, let's say you were trying to build a fully fledged solution from start to finish yourself, that would not have the same production quality as you might expect in a data set where actual people have replaced the words. But if you have a solution that's off the shelf, or at least built upon off the shelf blocks, let's say, how come that doesn't outperform a Wikipedia training set where not everything is necessarily synonyms? So I would imagine that if you have editorial history on Wikipedia, that some of the words would be synonyms that people replaced, but that other words would be simply mistakes as well that someone put in. Do you have some form of view there, like a theory why the Wikipedia-based information outperformed the synthetic one?
Okay. One thing that might happen is that we use the Wikipedia as a test set. So it's like the same domain and things like that. So it might be one case, right? The training part will probably fit better the test part if you are testing on it, other than other data set you create. That's one thing for sure.
Okay, so the validation was based on the Wikipedia page, but I guess out of sample data, at least from the Wikipedia.
Yeah, exactly.
Did you try any other metrics as well, or any other baselines apart from the Wikipedia set to validate this?
No, we didn't have like any data set at all. It was already, something not that obvious to use this data set as lexical substitution problem.
Mm-hmm. Okay, that's quite interesting. So you published these two papers, and then you've done quite a bit of other investigations as well that people can find on your webpage. Looking forward, because I see we need to wrap up this very soon. During 2023, what are you looking to do with bards.ai? Are you looking to deepen sort of your exposure to some of the new models that are out there? So let's say GPT-3 and similar, or do you have any clear objectives for this year?
Okay, we already have a project with ChatGPT there, with one of our clients or partners, you might say. And I think we are at the beginning of our journey. We have already these 4 co-founders and 3 employees, and in this year we want to maybe get, a few more projects and few more employees, but also, to build these structures, these processes inside our company that will, prosper better. Yeah.
Okay. And for people that want to get in touch with you, where would they be able to reach you?
For sure, on our site there is contact information. We also had this calendar when you could book a meeting, but we had a little issue there because Google released a BARD AI model, and people thought that we are doing this model, and they booked a lot of meetings like every day there, and we just had to tell them that we are not the ChatGPT solution. So we turned it off for now.
Okay. But then Bards AI is the webpage to reach you on.
Yeah, exactly.
Perfect. Are there any final comments that you would like to make before we bring this to a close?
Yeah, I think the AI field is really getting a lot of hype right now, but also it turns out a lot of things can work really, well, and we are living in really interesting times right now.
Great. So with that, let's bring it to a close. Thanks, Karol, very much for taking the time to speak to me, and have a great rest of your day.
Yeah, thank you too very much, and have a nice evening.